Hi class. This is, I already just made one video where I showed you how to do a regression problem. And now what I wanted to do was round things out by giving you a comprehensive review for test 4, just to kind of let you know the types of things that you are going to need to know for this test. So what I'm going to do is I'm going to use the whiteboard here to kind of assist us. So here's the whiteboard right here. So probably the first thing I want to make sure that you know how to do is make sure that you understand that the vertex form of a parabola is of this form right here. Okay. And then, of course, I want you to remember that the vertex for this one is going to be h comma k, okay? And you notice it's x minus h. H is positive in this case. And then plus k, it's obvious, plus k. And then this is for the coordinate for the vertex, which is going to be right here, okay? And then the other thing you need to know is if a is positive, then that means my parabola is going up. If a is negative, then my parabola is going down. So please make sure that you understand that, okay? And then, of course, standard form for a quadratic, we all know that. That's just going to be ax squared plus bx plus c. So please remember that as well. So let me move that down a little bit. Go back up here to the top, okay? And so, of course, just be able to make those determinations. So, for example, if I give you a parabola that's of the form f of x equal to minus x plus 2, quantity squared, and minus 3, and I want you to find the vertex for this. The vertex for this one is going to be -2, -3. Okay, why? Because it's x minus a -2, which is x plus 2. So that means there's a negative in front of the x coordinate, and then, of course, minus 3 just makes -3. And then you'll notice that a is -1. So what does that mean? It means that if I graph this, -2, go 1, 2 to this way, and 3 down. Here's my vertex right here, and this parabola opens down just like that. Okay? So just be able to do that and be able to understand how to identify the graph. Okay? So let me erase all of this. And then, of course, since you're watching this, it's obvious that obviously I'm recording this, but you can always rewind the recording if you miss any part of this. Okay? Sorry about that. Okay. There we go. Okay. So let's keep going here. Let's see here. Suppose we have a situation like this where we need to solve. So suppose we have x squared plus 4x minus 12 equals 0. And I want to solve this, so that means I have to factor. And this is just, I'm just doing this visually, just by observation. I need two numbers that multiply to -12 but add to 4. And that's very easy. That's just going to be plus 6 and minus 2. So therefore x plus 6, equals 0. And x minus 2 equals 0. So x is -6, x is 2. So my two coordinates, my two intercepts are going to be -6, 0, and then 2, 0. So visually, what's happening here? Okay, well, a is +1, so so that means the parabola is going up like this. And I know that at -6, 1, 2, 3, 4, 5, 6, there is an intercept, and then at +2, 1, 2, there's an intercept. And the parabola is going to do something like this. Whoops. Something like that. And somewhere down here is your vertex. And of course, we haven't calculated that, but you can calculate that. Okay? So let me move on down here. There we go. So let's see what else we can get ourselves into. Okay. What about this one? Let me move this over here so I can see this a little bit. Okay. So suppose I have a situation like this where I have h sub t, or h of t, and that equals to minus 4.9 t squared plus 370 t plus 94. And I want to find out, I launched this rocket at 0 seconds, and I want to find out at what time does it actually hit the ground, and where does it peak at, okay? So we know that on our planet, okay, whatever goes up must come down. So the rocket is going to come up, and it's going to come down like this. It's going to behave like a parabola. So this is at time equals 0, and this is at time equals question mark. That's one of the things I want to find, okay? And then the other thing they want to know is they want to know where the peak is. So in other words, they want to know the vertex, okay? So first things first, let's find the vertex. So the x-coordinate of the vertex is going to equal to minus b, which is minus 370, over 2 times a, which is minus 2 times minus 4.9. And if I pop out my little calculator here, here's my calculator, 370 divided by 2 divided by 4.9 gives me 37.75. So at 37.75 seconds, okay, that's where this thing is going to have a peak. So this is 37.75. So remember that all quadratics are symmetrical. So if I want to find the time it hits ground, that's very easy. That's just going to be 37.75 times 2. And I can do that right now, times 2. So that gives me 75.51. So the actual time it takes to hit the ground is going to be 75.51. Okay? But I'm not done yet. I have to find the intercept of the, the y-coordinate of the vertex. So what I have to do, I have to find out what h is at 37.75. And that's going to equal to minus 4.9 times 37.75 squared plus 370 times 37.75 plus 94. So we can do that calculation on our calculator here. So 37.75, and let's square that, times 4.9, and then change sign, okay, and add that to 370 times 37.75. That gives me this, and then plus 94 gives me 7,078.69, okay? So 7,078.69. Is that right? Yes. Okay. So that's going to be where it's going to hit the peak. Okay. So let's keep going. Let's see what else we can do here. So how about this one here? Suppose we have a break-even problem. And they tell me that the revenue function is 13x. And they tell me the cost function is going to be 0.0075 x squared plus x plus 2100. And they want to find out the break-even point for this particular situation. So break-even, okay, that means that R equals C. So 13x equals to 0.0075 x squared plus x plus 2100. So now I have to solve this for x. So I'll move everything to one side. And now I have to use the quadratic rule here. So this is going to be negative b, which is 12, plus or minus the square root of b squared. So that's going to be 12 squared minus 4 times a times c divided by 2a. So again, for those of you who don't remember the formula, let me do it right here. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. That's the quadratic rule. Okay? So now let's do this. So here's my calculator. And let's see here. We've got 0.0075 times 4 times 2100. That gives me 63. So that's going to be negative 63. So I've got 144 minus 63 gives me 81. And then the square root of 81 is 9. So this is going to give me, so if I just simplify what was under the radical, 12 plus or minus 9, okay? I got 63 for 4 times 0075 times 2100 gives me 63. 12 squared is 144. 144 minus 63 is 81. Square root of 81 is 9, okay? And then divided by, so let's do this down here, 0.0075 times 2 gives me 0.015. So my two answers, I have two answers here, okay? The first one is going to be 12 plus 9 over 0.015. And the second one is going to be 12 minus 9 over 0.015. Up here, I get what? 21 divided by 0.015, which is 1400. So this right here is 1400. And down here, I get 3 divided by 0.015, which is 200. Okay? So my two break-even points are 200 and 1400. Okay? And then it says here on the rest of the problem, it says find the maximum, okay, where profit is maximum. Well, that means find the for profit is revenue minus cost. So just remember that, if they're asking for profit, okay, profit is equal to revenue minus cost. And if they ask for the max profit, okay, then that means vertex. They want you to calculate the vertex, okay? So I won't do that, but that's pretty straightforward. So let's see what else we can do here. Okay, so here's one right here. Let's take a look at this one. So we have, and I think we've done one like this in class several times. We have a river, and we have three fences, three sides of a fence, and we want to create a rectangular area with 800 yards of fence, and we want to write an expression for the area, and we want to find the largest area. Okay, so we know that this is width and this is length, and we know that area is equal to length times width. And then we also know that the perimeter of our shape is going to be width plus length plus width, which is equal to 2 width plus L. And now I can actually solve this, okay, or excuse me, I actually know that this has to be 800, right? Because they tell me that I only have 800 feet of material, 800 yards of material. So now let's solve this equation for L. So L equals 800 minus 2W, and then plug this into this, okay? And they want A as a function of width. So A equals to 800 minus 2 width times width. So this is going to equal to 800W minus 2W squared. So this is the answer for the first question. And now they want us to find the largest area. So the largest area means vertex, okay? So the x-coordinate of the vertex is going to equal to negative b, which is negative 800, divided by 2 times a, which is negative 2. So this becomes negative 800 over negative 4, which is just going to be 200. So the x-coordinate is 200. And if I plug 200 into this equation, okay, or I can just use the perimeter equation if I want. Okay, remember the perimeter equation. It's probably going to be easier to do it this way. L plus 2 times W. So this is going to equal to L plus 2 times 200, which is equal to L plus 400. So therefore L equals 400. So the largest area is going to, so the length is going to be 400. The width is going to be 200. And the area is going to be 400 times 200, which is equal to 80000. So this is the maximum area. Okay? All right, let's see what else we can get ourselves into. How about this one? Suppose we want to write in a quadratic equation, and they give us the solutions, and we want to write the equation in standard form. And they say that x squared should be the smallest positive integer coefficient that will work. Okay? So what are they asking me for? Okay? Well, they tell me that x equals negative 4. And they also tell me that x is equal to 9. So that means that x plus 4 equals 0, and x minus 9 equals 0. So x squared plus 4 times x minus 9 equals 0. So if I FOIL this out, I get x squared plus 4x minus 9x minus 36. Okay? And I can drop this part now, right? So now x squared minus 5x minus 36. So this is going to be the smallest answer I can get. Okay? So in this case, I'm assuming that A is 1. Okay, but if they didn't tell me what A was, I'd have to put an A term right here, and I'd have to multiply this all by A, and then I have to multiply A back right here, and they would have to give me a point in order to solve what A would be. Okay, but that's not necessary. Okay, because they tell me make it the smallest one. So the answer that I'm going to put in is going to be x squared minus 5x minus 36. And then that's going to equal 0. Okay? Let's see here. So let's look at this graph here and see if you can figure this out. So let me go down here. Okay. So look at this graph here. Okay. So it says, I hate it when it does that. It says here, which labeled point A through G corresponds to the release of the ball. Okay, so the release of the ball is going to be A, right? How high in feet was the ball when it was released? So you can just count up here and you can see. So I've got 1, 2, 3, 4 to get to 32. So it looks like this is increments of 4. So 8, 16, 24, 32, 40, 48. So it looks like it was 48 high when we released it, right? So each one of these tick marks appears to be 8 units, right? How do I know that? Because here's 0, and I've got 1, 2, 3, 4 to get to 32. So that means that 4 divided by 32 is 8. Each one of these tick marks is 8. Okay? Let's see here. Let's do one more word problem, and then we'll call it a day. Okay? So this is another word problem, and they give us a coin. No. There we go. H of t is equal to minus 16t squared plus 128t plus 320. And this is a coin. We throw off an office building. Okay, from what height is the coin thrown? Include units. At what time does the coin hit the ground? Okay, so let's draw a picture of what's going on. So here's the building. And I throw the coin. There's the coin right there. Here it comes. It's going down. It's hitting the ground. Bam, there it is. So there's the coin on the ground right there. Okay? So clearly the coin is thrown up in the air. So we want to find out what is the height when what height is, what is this height right here when I throw the coin? Okay? So in other words, they want me to find out what the height is when t equals 0. So when h is equal to 0, I get 16 times 0, which is 0, plus 128 times 0, which is 0, plus 320. So the height is 320 when I throw the coin. At what time does the coin hit the ground? Okay? So when the coin hits the ground, then that means that h of t equals 0, which means this equation here equals 0. So I have to solve this equation, and I'm going to have to use the quadratic rule in order to do this. Okay? So remember, the quadratic rule is minus b plus or minus the square root of b squared minus 4 times a times c over 2a. And here a is minus 16, b is 128, c is 320. So this becomes negative 128 plus or minus the square root of 128 squared minus 4 times a minus 16 times 320 divided by 2 times a negative 16. So let's do this on the calculator. So 4 times 16 times 320 gives me 20,480, and remember, a negative and a negative makes a positive, plus 128 squared equals 36,864. So this becomes minus 128 plus or minus square root of 36,000, what was it? 864. And all this is divided by negative 32. 16 times 2 is negative 32. And now let's take the square root of this. So that gives me 192. So this becomes, let me write it right here, minus 128 plus or minus 192. So 864 is a perfect square, and it's 192. So I get this. So this gives me two solutions. The first solution is minus 128 minus 192 over minus 32. And then the second one is minus 128 plus 192 over negative 32. And this one right here is going to be bogus, right? Because 192 is bigger than 128, which gives me a positive divided by a negative. So this one's not going to be possible, but this one is. So let's look at this one. So 128, change sign, minus 192. And then divide that by 32, change sign, and that gives me 10. So the answer is 10. Okay? So I hope this was helpful. So remember that your test, what I've done is I sent an announcement about this morning. I have extended all of the work in Chapter 6, 6.1, 6.3, 6.4, 6.6, and Test 4 until March the 27th. So you will need to be through that material and have Test 4 completed by March 27th. And the types of problems that I've done in this review are pretty much the only types of problems that you're going to see. There is a regression problem, but I did that in the other video that you saw. And that should pretty much do it. Okay? So as you saw there, I was using Test 4 as my guidance for this review. Okay, so I'm trying to give you questions that are directly on point with what you're going to be responsible for. Okay? Thank you.